Okay, now we want to talk about the concept of refraction. So the definition of refraction is it's going to be the bending of a wave as it goes through something. So reflection was going to be the bending of a wave when it bounces off of something. Now we're going to go through something, and light is going to bend depending on what the substances are that the light is traveling through. So if you recall, the formula, it's not much of a formula, but the formula for reflection was that the angle going into a mirror had to equal the angle coming out of the mirror. And so we had a situation like this where it went in, and then this angle equals that angle over there. Now we want to have a fundamental formula that is going to predict how much light is going to bend when it goes through a material. And so what we can do is, let's say that this is a piece of glass. And now the light is going to go into the piece of glass over here. So here's the incoming light, and then it's going to bend. Now we can make a perpendicular to the piece of glass the same way that we made a perpendicular to this one over here. So again, we're going to have an angle that is going into the piece of glass. And then we're going to have the angle that it makes inside the piece of glass. So let's pretend that this was air down here. Let's pretend that this is air right here. What would happen? Well, the light would just go in a straight line like this. So light would go in a straight line if there was no change in the material. But because it's going from a less dense material into a more dense material. Now when I say the word dense, I'm talking about optical density. So how much does it resist light when light tries to travel through it? So let's pretend that this is made of glass, and so this has an optical density that is greater than air. It resists light more than what the air does. So if this was air, it would go in a straight line. But because it is resisting the light, it's going to cause it to bend. And it's going to bend it in, well, let me switch to a different color here. All right, so it's going into it like this, and then it's going to go in that direction. So do you see how it bent when it went into the piece of glass? Well, we can predict how much it's going to bend. And we start off making our formula look very much similar to this one over here. So this is the angle that it's making coming out, and then here's the angle going in. But we need to put the sine of the angle going in, and we need the sine of the angle coming out. Now, don't worry about this. If you have a calculator, you might notice it has a button that says SIN. So that's trigonometry. So that is the sine function. So that you could, if you wanted to, actually calculate how much the light is going to bend by using the sine function. Now, we're not going to do it in here, but if you take more advanced physics classes, you would learn how to do this. So we're going to put an equal sign in there, like we have up here. So the sine of the angle going in, and we've got the sine of the angle coming out. So this was the angle going in. Where's the angle coming out? So that is going to be this one right here. So this is in, and then this one up here, this would be the out. So the angle it's making coming out of that substance there. Well, still, there's one more thing that we need to take care of we need to take into account the density of this material and the density of this material, and that's where a thing called the index of refraction comes from. So we're going to put a constant called the index of refraction, and it's going to be the letter N. And we're going to say N in. So this would represent what is this substance down here. Is this substance air? Is it water? Is it glass? So every substance is going to have its own index of refraction. And the index of refraction is going to be related to how do the atoms in this material respond to light. How does the light interact with the atoms? And that's all incorporated into this constant. Well, we need to have another constant over here. So this would be the index of refraction for this material, and I'm going to put out. So we've got the index of refraction of the material where the light is going in, and then the index of refraction where the light is coming out. But notice that the equations here, they're kind of similar to each other. They both have something to do with the angle, and we could even, if we wanted to, so this has a index of refraction. So this would be in, and then this is in out over here. So let's go ahead and do it. So we could put N in, and we could put N out on this one, but what do you notice? They cancel out. So since they're both the same material, when it bounces off the mirror, the ends cancel out. So we can make the two equations even look more alike by putting in the index of refraction like we did. All right. Was that interesting? I hope that was interesting to you. I just thought it was kind of fascinating. So the point is, I want you to be able to predict whether the light is going to bounce in this direction or whether the light is going to go in this direction. And whether or not it goes this way or this way depends on the density of this material versus this material out here. So I want to explore that in more detail. Why does the light bend when it gets into a different kind of material? Okay, and the answer has to do with how does light interact with atoms. Okay, now we know that light travels at the speed of light. No big deal. But when light goes through a piece of glass, it slows down. And so now you're saying, well, how is that possible? If light can only travel at the speed of light, how can light slow down when it goes through this? Okay, so in order to understand this, I want you to think about an interstate highway that is going right past a city. Okay, so let's pretend that we have an interstate highway that's going in this direction. And let's say that you've got a car that is going at 60 miles per hour or 60 kilometers per hour. So it's going at a pretty good clip. All right, and it's going in this direction, and it's got a choice. It could either continue on the interstate going at 60 kilometers per hour, or it could go through a city. So let's pretend that here is a city, and so the car gets off the road and it goes through the city, and then it gets back onto the interstate. But the problem, though, is that there are stoplights. So you have a stoplight located here, a stoplight here, and a stoplight here. So here you've got this car that is going at a pretty good clip, but it has to come to a screeching halt right here. So it has to slow down and come to 0. Well, this is like light having to interact with an atom. So depending on the atom, light can really make those electrons jump up and down, which means that the light interacts with the atom. Okay, now as soon as it's finished, the light comes out of the atom at what speed? The speed of light. So it's going at the speed of light until it gets to the atom. Then it interacts with the atom, and then it goes at the speed of light until it gets to the next atom, and then the next atom. So if you were to average the time that it took to go through all of these different atoms, just like a car having to stop at stoplights, you would find its average speed was slower. So it was going at like 60 kilometers per hour up here, but when you have to come to a stop and then start, stop, and start again, your average speed when you get through here is going to be less than 60 miles per hour. Even if you're going 60 miles an hour or 60 kilometers per hour from here to here, and then you're going at 60 kilometers per hour from here to here, your overall speed is going to be less. And so that's how light slows down when it goes through a piece of glass or air or any kind of a substance. So the next thing is, well, how does that cause bending? So how would that cause light to bend just because it's slowing down? And so that's what the second picture is for. So the second picture is going to show a car going from dry grass onto mud. So here we've got a car up here, and now this represents the 4 wheels on the car. And originally the car is going to be in dry grass. The car is going in this direction, and then it gets into mud. So here's some mud right here. And so now again, let's draw the car as it's entering into the mud. Which wheel gets into the mud first? It's going to be this one right here. So that wheel is stuck. It slows down. But notice that this wheel over here is still in the dry grass, so it's going at its normal speed. So this one slows down, this one's going at its normal speed. What's going to happen? The car's going to pivot. So the car is going to pivot in this direction. So when you're going, so if we were to make a line like this, so that represents the direction the car would go if this was still dry grass. We can predict which way is it going to bend. So you notice that it's bending in this direction. Now what do you suppose would happen if instead that the car was going this way? What would happen? So we can do the same thing. So if we pretend that here is the car, and then here's the wheels, this time what's going to happen is that, so here's the direction it would go if it wasn't being bent off course, and this time this wheel here is going to get into the dry grass first, and it's going to get traction. So if it gets traction, this wheel will speed up, and so which way is it going to bend? So it's going to bend off in this direction. So what I want you to see about that picture is no matter whether the car is going this way, it bends this way, but if it's going this way, it bends that way. So it doesn't really make any difference which way the car is going. The angle is going to be the same. So this is something I'd like for you to be able to do on the exam, is predict the direction that light is going to bend whenever it gets into different kinds of materials. Okay, let's take a break, and when we come back, we will talk about how refraction makes objects appear to be in different places.